So let's look at bond enthalpies. Let me start by reading out the definition. It is the amount of energy needed to break a covalent bond, creating individual atoms during a chemical reaction in the gas phase. So, what this means is if I take HCl gas, in order to break this, I need to give in some energy. I need to break the bond that is that is between this compound. So, in order to break this, I need to supply an energy of plus 431 kilojoules per mole. And once I supply this energy, it will be broken down into hydrogen gas and chlorine gas. Now, I'm stressing on gas because that's what the definition is. This bond enthalpy can happen only during the gaseous state. Another important thing to note is that we have something called average bond enthalpy. And this the meaning is that when we look at the carbon bond in ethane and the carbon bond in pentane, they are different. And in order to get an average value, in order to understand what is the amount of energy needed to break this carbon bond, we use average bond enthalpy. And so let me just read out the definition so you'll be able to understand. It is the average value of the enthalpy required to break a given type of covalent bond, in this case which is carbon, in the molecules of a compound in the gaseous state. So now we know what is bond enthalpy and now we know what is average bond enthalpy. So let's do an example. I'm going to take the example from the chemistry reader, page 13 of unit 2. And the question is, using average bond enthalpies in the table below, calculate the standard enthalpy change of reaction for the complete combustion of methane. When you look at bond enthalpies, you don't have to worry about whether it's a standard enthalpy of formation or standard enthalpy of combustion. That's not important. In this, we need to look at how the bonds are. So the equation which they have given us is CH4 plus 2O2 gives carbon dioxide and water. So now let's show these as they are in bonds. So in order to draw a bond, we know there is one carbon. So okay, so I'm going to take this compound first. So it's going to be, because there is only one carbon, I'll show one carbon, and four there are four hydrogens. So one is going to be this side, one is going to be this side, one is going to be this side, the other one is going to be this side. So if you don't understand this, it's the same as writing, because carbon has four electrons in its outermost shell. You have one here, oh, four electrons in its outermost shell. Hydrogen has one electron, so it needs one more to complete its outermost shell. So what hydrogen is going to do is it's going to supply one electron, which I'm going to represent with a cross, and this is, so now hydrogen has one complete outer orbit, but carbon needs four more to complete its outer shell. So another hydrogen is going to come and bond with this. And then we have another hydrogen here. And we have another hydrogen here. So therefore, carbon has has 8 electrons altogether, and each hydrogen has 2 electrons, which is full. So when only one electron is shared between the atoms, that's when it becomes a single bond. Suppose if there were two atoms, it would be represented with a double bond, which you will see now when we do for oxygen. So this is how it's done for CH4. Let me write that down. Now we're going to look at oxygen. And so oxygen, can you see that there are two oxygens? Oxygen is a double bond O. Now oxygen, to show this bond, it will be, now oxygen has 5 electrons in its outermost shell. So we've got 2 here, 2 here, and 2 here. And oxygen needs 2 more electrons to complete its outermost shell. So another oxygen is going to come, which has the same number of electrons. I'm going to draw them here and here. So now what happens is these electrons, they come together. Or another way to draw this is, I should have thought about that before I drew this. Okay, so I'm going to take a blue color to, so you're going to take, I'm going to cross it. That's better. 2 crosses here, 2 crosses here. So altogether, you can see that including these green dots, so we've got 1, 2, 3, 4, 5, 6, 7, 8, which completes this oxygen outermost shell. And here we have 1, 2, 3, 4, 5, 6, including these crosses, we have 8 electrons in the outermost shell. So therefore, because there are 2 electrons, it becomes a double bond. And since we have 2 oxygens, we are going to have 2 double bonds. So this is for 2O2. Now we're going to take a look at carbon dioxide. So for carbon dioxide, carbon has 4 electrons in its outermost shell. So we're going to represent those two. And oxygen needs 2 electrons. So therefore, I'm going to bring this in. I'm going to do a cross here. And another oxygen is going to come here. Oh, here. Oh, this doesn't come. That's not that. So can you see that including all of this, it becomes 8 electrons. Here it's 8 electrons so the both hydrogen outermost orbital is filled. And for carbon, if you take these two these two oxygen electrons, and add them up to the um, already 4 electrons for carbon, you'll get 8. So therefore, they filled their outermost shell. So because carbon is sharing 2 electrons and oxygen is sharing 2 electrons, it's going to be O double bond C, and carbon is also sharing 2 electrons with this oxygen, so it becomes double bond O. And last but not least, let's move on. So there is only one carbon dioxide, so it's like that. Next, we've got 2 waters. Now for water is a little more trickier to draw. So we've got oxygen, again. And here we in oxygen we've got 5 electrons, so we're going to have 2 here, and we're going to have 1 here, 1 here, and 1 here. Now the reason why I'm drawing it like this is because the hydrogen is going to come towards this side. Hydrogen is going to come with its 1 electron here, and the other hydrogen is going to come with its other electron, which is here. And so can we see that hydrogen's outer orbital is filled, this hydrogen's outer orbit is filled, and this oxygen's outer orbit is filled. So therefore we can say that oxygen, because there is only 1 electron shared, it will become a single bond H. And here also, since there is only 1 electron being shared, there will be single bond H. Now on top we can see that they are asking for 2 waters, so we're going to have 2 of this. Just going to draw an extra one here. So this is the complete breakup of how you would find out whether it's a single bond or a double bond. So let's now put this, leaving this aside, let's put this together in the equation. Let's substitute our way of drawing this into the equation. So we've got, in place of CH4, I'm going to write it like this. I've got plus. Now in place of oxygen, I'm going to show double bond. And this gives us carbon dioxide, which is O double bond C double bond O, plus we've got 2 waters, so it's going to be H. So O, 1 bond H, 1 single bond H, and another O single bond H, single bond H. So this is another way of representing, and the reason why we are doing this is because in the data table you can see that they've given C single bond H, O double bond O. It's not given as the equations themselves, so by splitting this up you will be able to find out, you'll be able to find this out easier. So now let's go on to the maths. So we are going to calculate the energy required to break all of the bonds. So we're going to consider this side as the energy to break, and we're going to consider this side the energy to make. So now when we need to make this, for this side I'm going to, now in the data table they have given C single bond H. Here we can see that there are 4 bonds like that. So we're going to do 4 times the value for, I'm just going to write it like this because this is the first time you're doing the example. So I'm going to write it in the easiest form. And we've got 2 uh, double bond O's. So we're going to put 2 double bond O. And on this, I'm just going to put a little break so we don't get confused. And we've got 2 because this is 1 and this is 1. We've got 2 C double bond O's plus here we've got 1, 2, 3, 4. We've got 4 O double bond H. So now let's substitute the values. So for C single bond H is going to be 413.